Okay, this is Unit 4, Lesson 6, Video 1. So we're going to look at graphing a linear inequality. Okay, so graphing a linear inequality, we graph pretty much the same way we graph an equation. So my slope is 3 over 1. Whole numbers are fractions when we graph. And my y-intercept is 1. Okay, so if I go to graph this, I am going to start at 1 on the y, and then my slope is 3, so up 3, right 1. Oops. Or down 3 and left 1. Okay, so putting the points on the graph is the exact same with it, whether it's an equation or an inequality. However, there's some things I have to note about the inequality signs. So when it's a less than or greater than, so one of these, then on a number line I know that would be an open circle, and so that corresponds to a dashed line on a graph. Okay, so on my graph, I need a dashed line. So it's still going to go all the way through, and it's still going to have arrows at the end. Okay, some other things to note. That we have shading. So remember on a number line, if it's greater than, you're shading to the right. If it's less than, you're shading to the left. So this is greater than, we would shade to the right, but what that actually means on a coordinate plane is above or below. And to tell if it's above or below, you start at the y-intercept and you shade on the side of the line that's above. So above y-intercept. So shade above y-intercept, shade below. So if it's less than, you shade below. This one's greater than, so I find my y-intercept and the side of the line that's above. So if I go above, that's this way. So I'm shading on this side. So I'm going to take my pencil. You don't have to use a color, but you can. And I'm shading this whole side of the graph. Okay. I don't stop at the axes. The axes don't mean anything. I go all the way to this line. So on a number line, the equal to sign was a closed circle, so that just means a solid line. This is greater than, so again, shade above y-intercept. Solid line. And it's less than, so shade below. Okay, let's look at some more examples. Alright, so again, I'm going to graph this just the same. I'm in slope-intercept form, so I'm going to start at -3. My slope is 1/2, so up 1, right 2. Or down 1, left 2. Okay, it's equal to, so I need a solid line. I need to change that. Back to solid. Okay, solid line. So your line makes the graph, divides the graph into two regions. Okay? And then it's less than or equal to, so I shade on the side of the line below the y-intercept. So here's my y-intercept. I want to shade below, so this way. So I shaded everything underneath this line. And remember, I don't stop at the axes. Okay. I would pause and try this one on your own. So we want to start at 4 on the y-axis. Just marking my field. My slope is -3/2, so I'm going to go down 3 and right 2. I can also go up 3 and left 2. Again, there's an equal to, so this is a solid line. Okay. So, fix this a little bit. There we go. Greater than or equal to means shade on the side of the line above your y-intercept. So over here. So this whole side of the graph. Again, I'm not stopping at the axes. I stop at my line that I've graphed. Okay, if we have them in standard form, then we want to change them to slope-intercept form because you can't read your inequality sign like the above or below unless it's in slope-intercept form. So I first need to subtract 2x and then divide by 7 so I can put this in slope-intercept form. Inequality rules still apply. So if you were to divide by a negative, you would need to flip your sign. 7 is not negative, so I don't have to worry about that. And that's 3. Okay, so my slope is -2/7. My y-intercept is 3. Okay, so graph your points. Start at 3. And we're going to go down 2 and right 7. We'll go up 2 and left 7. Okay, this will be a dashed line because there's not an equal to. Oh. Whoa, hold on a second. Okay. Let me go ahead and draw this in and then I'm not sure why it didn't change for me. Oh. Okay, now it did. I want this to be dashed, so just dash it like this. Okay. And it's greater than, so I need a shade on the side above the y-intercept, so up here. Same thing for this one. We need to subtract 5x from both sides. Divide by -3, and it's an inequality, and you're dividing by a negative, so you have to flip the direction of your inequality sign. That will be positive 5/3 x, and this will be positive 5. So start at 5. Going up 5 and right 3. You can also go down 5 and left 3. Okay. This is going to be, again, a dashed line. There we go. Okay, put my arrows at the end. It's greater than. I look at what it is in slope-intercept form, not back here as standard, but slope-intercept. So I shade on the side that's above the y-intercept. So everything on this side of the line. Okay, so what the shading means is that any point inside this shaded region is a solution to my inequality. It's a true statement. So for example, let's say I'm just picking this point here. That's 1, 2, 3, 4, 1. So -4, 1. So that means if I plug -4, 1 in for x and y, I'm going to get a true statement. So that's -23. Well, -23 is less than -15. Yeah, that's true. So that's just an example. All of these points in the shaded region are true for that inequality. Okay, this is the last assignment from Unit 4. Unit 4, Assignment 9.